Hello friends, today we will discuss the signal system, type of signal and working of different type of signal, behavior of different type of signal. Let's discuss first type of signal. First type of signal is continuous time step input signal. The step input signal is defined as ut is equal to 1 for t is greater than 0, but it has no value for t less than 0. See here, for t greater than 0, it has value is equal to 1, but when t is less than 0, it has no value. It means it has 0 value. Now see the discrete time unit step signal. It seems like continuous time signal, but something different in discrete. It has discrete value for for n is greater than 0, but it has 0 value for n less than 0. See, it has magnitude 1 as at n is equal to 1. It has magnitude 1 at n is equal to 2 and so on 3, 4. It has a discrete value for integral n. For each integral n, it has discrete value. You can see here un is defined only where n is greater than 0 and where n is less than 0, then magnitude is 0. Now let's see a unit impulse function in discrete domain. It has only one value at n is equal to 0. See here, it has only one value at n is equal to 0 and denoted by delta n. Here delta n is defined as n is equal to 0 at value of delta n is 1 and where n not is equal to 0, it has 0 value. See here in figure and see also you can see here in definition. Now, property of unit step function is here un minus 1 is equal to delta n. Definition of delta n is un minus 1 is delta n. Here, this is un, this function is un, and this one is un minus 1. It's shift by one integer, shift it's shift by one integer. This is un minus 1, and this one is un minus 1, and you can see this figure is something like impulse function. It has only one value at n is equal to 0, but it has no value other than n is equal to 0. Now you can shift the impulse function and delta, you can find n delta n minus 1, and in delta n minus 1 the origin will shift on n is equal to 1. Here if you want here, then you can put that for delta n minus 1 you can put n minus 1 is equal to 0. For here you can get n is equal to 1. For here you can get n is equal to 1. It means the magnitude which are at origin will shift on n is equal to 1. This magnitude was on origin and now it will shift on n is equal to 1. This is 1. This is 1. Similarly, if you want to draw delta n minus 2, then you can write here n minus 2 is equal to 0. For here we can get n is equal to 2. It means the value at origin will shift by 2 unit, and it means this will be 2. And if you want to add delta n and delta n minus 1, delta n minus 2, then add these all figure and it will become like this. Now, differentiation of unit step signal will be impulse function, impulse signal, and integration of unit impulse signal will be unit step signal. You can see here. Continuous and discrete signal. Let's see continuous and discrete signal. The continuous signal have a value is defined for your instant of time. Considered interval, however, a small interval is called continuous time signal. Discrete time signal is derived from continuous time signal through a process called uniform sampling. Hence, it's defined as discrete value for time. Basically, continuous all value are sine theta, cos theta, sine, cos, tan, all are continuous signal. If you want discrete signal, then you need uniform sampling. Uniform sampling, you can get discrete signal. For discrete time signal Fn, the argument n must be integer. In constant argument t, continuous time signal can be any real value. T can be any real value, but n will be always integer. A continuous time signal ft is uniformly sampled to form a discrete time signal f n ts such that t is equal to n ts, where ts is the sam ts is the ts is the sampling period. Ts is the sampling period, and n will be in integer 0 plus 1 plus 2 minus 1 minus 2, whatever. This is a sine wave. This is a discrete sine wave. Let's see, this is a sine wave. This is a sine wave. You can see here, this is a sine wave, and you can make it some discrete with the help of uniform sampling. After uniform sampling with sampling time Ts, you can get this discrete time signal. The continuous time signal ft can be defined either in the form of mathematical equation or in graphical form. On the other hand, along with the mathematical form graphical representation, the discrete time signal fn can be represented in set of values shown below. There are arrow indicate the amplitude. Now, come to even signal. Even signal are those signal which have same value after the reversing the sign of t. For here, if let's a function ft, assume a function ft, and if ft is equal to f minus t, then this function will be even signal, otherwise it will be odd signal in continuous domain, and similarly in discrete domain, if fn is equal to minus time, fn is equal to f minus n, then this signal will be even signal. Consider this example. This is ft and this is f minus t. It both functions are same. Both functions are same because this graph and this graph are same. And after putting minus in t, this will replace by this part, and both are same. That's why there is no change in the signal after putting minus with t. Now come to odd signal. Odd signal are those signal in which ft is equal to minus time f minus t. F minus t is equal to minus time ft in continuous domain in continuous time signal. It will be odd only when f minus t is equal to f minus ft, and in discrete domain f minus n is equal to minus time fn, then it will be odd signal. Consider this signal. This is sine wave. This is sine wave, and if you put t to, if you replace t to minus p, then graph will be something like this. This f minus t and f t are both not same. That's why sine are odd function. It's not even function. Now, you can calculate the even part and the odd part of any signal. If you want to calculate even part denoted by FET, FET will be, that is even part of signal, FT plus F minus T by 2. And if you want to calculate odd part of any signal, FOT will be FT minus F minus T divided by 2. Just Just this in even part, this will be plus, and in odd part, this will be minus. Other are same. Now come to periodic signal. Periodic signal are those signal which are repeat itself after a certain time. After a certain time, it repeat himself are called periodic signal. Here we can see ft is equal to ft plus minus kt. It means t is the period of signal, and it repeat itself after t. K will be integer. K will be integer here. It means it will repeat the signal after 1t, 2t, 3t, after each integer of t, where t is the 1 upon 2 pi 1 upon frequency, 2 pi omega, 2 pi by omega. And in discrete domain, Fn, in discrete domain, signal will be periodic only when Fn is equal to Fn plus n, where n is the period of signal. It means after n time, signal will repeat itself. N is the fundamental time period. N is the fundamental time period where n is the number of sample taken by signal repeat the same pattern. Let's see, this is the continuous periodic signal. This is continuous periodic signal. It repeat himself after 1.5 second. This is the time period 1.5 second, and it repeat himself after 1.5 time. This will copy after 1.5 time. It again copy this part to 3 second and so on. That's why the signal is be periodic with period t is equal to 1.5 second. And same for discrete time. And same for discrete time. This is discrete signal and it repeats himself with the after n is equal to 5. It means its period is n is equal to 5. Now come to energy signal and power signal. Energy signal are those signal. Energy signal are those signal which has finite energy but it has zero power. Energy signal are those signal which has finite energy is in between 0 and infinite, and power will be 0 as called energy signal. But power signal are those signal in which power will be finite, but energy will be infinite. If you want to calculate the signal is energy or power signal, then this is the formula by which we can calculate energy or power of the signal. And if we got finite energy, then signal will be energy signal. And if you got finite power, then energy signal will be power signal. Normally, periodic signal are power signal. Let's see how can calculate the energy of the signal. This is formula how to calculate the power of the signal. This is time period, t is time period, and integration of minus t by 2 to plus t by 2. xt signal, ft is signal, xt square dt watt, and this is formula for energy. Limit dt to infinite integration of minus infinite to plus infinite xt square dt cube. Now, if you want to calculate, this is a example. We have a signal A sine omega t. As you know, the signal is periodic signal, and I have discussed earlier that each periodic signal are power signal. That, that's why I know that this signal will be power signal, but you want to calculate the energy and power of the signal. I know for power signal, energy will be infinite, but power will be finite. Let's see how can calculate the energy and power. This is formula for calculating the power of signal. Here, xt is A sine omega t plus phi, and t is the time period. Then you can replace this by trigonometry formula. We can replace this, and after integrating this whole, we can get a square by 2. Normally, power of the periodic signal is the amplitude square by 2. We can check this. It's the amplitude square by 2. We can get here a square by 2. And if you want to calculate energy, then you can get energy here. Infinite, it means signal is power signal. It's not a energy signal. For discrete time, formula for an calculation of energy is E is equal to minus infinite summation of minus infinite to plus infinite xt square, and for calculating of power, limit n to infinite 1 upon 2 1 plus 1 summation of minus n to plus n xt square. Now come to causal and non-causal signal. Causal and non-causal signal. Causal signal are those signals which are defined for t is greater than 0, but it's not defined for t is less than 0. It means it has some magnitude only for t is greater than 0, but it has 0 magnitude for t is less than 0. Ut, this is unit step function. It has magnitude for only positive t, but it has no value for negative t. It means it is a causal signal, but in non-causal, it has magnitude. It has some value for t is less than 0. Ft will be not is equal to 0 for t less than 0. Here t is less than 0 and it has magnitude 1. That's why this signal will be non-causal signal.